Hello and welcome to another of our short introductory videos related to practical temperature metrology. And we're looking at the gallium fixed point in this session. Gallium is a metal with a low melting point. It melts at 29.7646, and here I've got some gallium which is in the liquid phase. Gallium is fairly easy to obtain at high purity, and it's used in the semiconductor industry. It's also one of the defining points on the International Temperature Scale of 1990, ITS 90. So I have a practical gallium fixed point cell here. The SPRT, or the thermometer being calibrated, comes into the tube here. The cell's sealed, the thermometer doesn't make direct contact with the metal. And you can get gallium cells in different sizes. This one's ideal for SPRTs. This is we call it a slim gallium cell. It's a smaller cell and can be used more with smaller thermometers. The temperature inside the cell will be the same. It's the gallium melting point, 29.7646. But we would need a longer cell for a long SPRT so as to reduce immersion effect. With a smaller thermometer, we can use a smaller cell. So these cells are sat here at room temperature. In order to use them as a calibration point, we need to be able to melt and freeze the gallium inside the cell. So I could do that very simply with hot water. I might use a dry block calibrator or perhaps a liquid bath. But if I put the Isotech cells into liquid, I do need to make sure that they stay dry, that the water is not in direct contact with the cell. And you can do that with some application notes on the website about using the cells in a simple way. It's a lot more convenient to use a dedicated apparatus. This is the Isotech gallium apparatus, and it's simplicity itself to use. The moment it's sat here, the metal's solid. And to use it, I simply change the control from freeze to melt, and the apparatus will heat up to a certain temperature to start to make the metal melt, to change to a liquid from a solid. As that starts to happen, the temperature is automatically lowered. We'll have a period, maybe 12 to 14 hours, where the gallium inside the cell is going through the phase transition, and we have the reference point. At the end of the process, the metal will all become liquid and will rise to the same temperature as the apparatus. And then we can simply turn the switch back to freeze, and the cell will be cooled from the bottom up, ready to be used the next time. When gallium freezes, it expands by about 3%. So it's important that the cell is arranged so it freezes from the bottom up, so as to avoid stressing and rupturing the cell. And with the Isotech apparatus, that happens automatically. And even with power failure, the apparatus ensures the cell is frozen from the bottom up. So the gallium fixed point is really useful in temperature metrology. In an earlier video, we've looked at the water triple point cell and how that's fundamental for the calibration of SPRTs. But if we check an SPRT at a single temperature, we can know its resistance at that temperature. But it only tells us information at that point. If we put an SPRT into the gallium cell and measure the resistance at the melting point of gallium, then we've got extra information. And one very useful parameter to have is the ratio of the resistance of the SPRT at the water triple point to the resistance of the SPRT at the gallium melt point. And the ITS 90 specifies for an SPRT that ratio, often referred to as W gallium, has a value greater than 1.11807. And that information relates to the purity of the platinum wire. And so we can track and check SPRTs very usefully with a water triple point measurement and a gallium measurement. For industrial thermometers, the ratio will be different because the wire used in industrial thermometers has a different purity to that used in SPRTs. But again, in a calibration lab, having W gallium measurements for reference thermometers is very useful indeed. It tells us about the purity of the platinum It helps us to be confident in the thermometer's performance at different temperatures, and it's really useful for laboratories. Just a couple of final thoughts relating to gallium cells. They're relatively robust, they're less fragile than certainly the quartz or the borosilicate water triple point cells. They're best stored upright, so if the environment gets warm, the metal will melt and it will be in a known state. The big thing to know about gallium cells is that gallium is considered hazardous, and particularly when it's being shipped on an aircraft, special regulations apply. And that's because liquid gallium will dissolve aluminium, which is a risk to the aircraft. So when a gallium cell is shipped on an aircraft, it has to be packed in dry ice to be sure that the gallium is in its solid phase. Other restrictions apply when it's shipped by road, but there's still regulations apply, and it's important to follow those. So that completes our very quick look at the gallium fixed point cell. There's lots of information on the Isotech website. We've got some links to share with you. One of them is for an article called Why Laboratories Need Water Triple Point and Gallium Point Cells, and that refers to W gallium that I mentioned. And there are also more detailed technical articles. Thank you very much for watching the video. We'd encourage you to like or subscribe to keep in touch with new videos from us.